All right, guys, in this lesson, we're going to be looking at confidence intervals for the differences of proportions. So really our objective here is just to describe the center, shape, and spread of the difference in two sample proportions, determine the conditions for the difference of proportions, and construct and interpret a confidence interval for the difference in two sample proportions. So in all honesty, this is not much different than what we learned when we took a confidence interval for one sample. We're just adding another sample to that problem, and then we are taking the difference between one sample and another sample. So not a ton of new information here, just trying to understand how we take the difference instead of just finding one confidence interval. So in comparing two proportions, really what we need to know is that you're going to have two sample populations, basically. And then you are going to have two statistics, essentially from those two different samples with their own different sample sizes. So if we want to compare the differences in these populations, we can compare the differences in the samples. Essentially, we can take whatever we get for the first sample, or the proportion for the first sample, minus the proportion for the second sample, and that essentially gives us the difference in two proportions, basically. But in order to do that, we must know what the sampling distributions are. In other words, they must be normal, basically. So let's look at this example real quick. Suppose that there are two large high schools in one town, each with over 2,000 students. At school 1, 70% of the students did all of their homework last night. Only 50% of the students at school 2 did all their homework last night. So the school counselors want to know if there is a difference in the proportion of students who are doing all their homework. School counselor 1 takes a simple random sample of 100 students, and school counselor 2 takes a simple random sample of 200 students. What can we say about the difference in proportions at the two schools? So first thing we need to understand is that we need to look at the shapes of these distributions. So A, over here, is going to represent the sample proportion for the first school. So basically, it's a proportion of the successes in 1,000 simple random samples of size 100 from that first school, from a population with a proportion that's 70%, basically. And you'll notice that that sampling proportion looks approximately normal. Kind of goes on a bell curve right there. B is basically the sample proportion for school 2. And again, looks approximately normal. So C is representing the difference in sample proportion. So basically the difference from this proportion and this proportion, and you'll notice that it also looks approximately random, or approximately normal, excuse me. So what we need to understand is that if we take a sampling distribution of one sample and a sampling distribution of a second sample, they both need to be normal in order for us to be able to find a confidence interval for the difference in those two sample proportions, basically. So the second thing we need to look at is we need to find our values of interest, or basically our shape, center, and spread. So we know that based on this problem, the sampling distribution for the proportion 1 and proportion 2 were both approximately normal in this case. We can also confirm that through our large counts condition as well, by just taking 100 times the proportion for success and 100 times the proportion for failure. We know that both of those numbers are going to be greater than or equal to 10. We know that it's going to be the exact same scenario for our second sample proportion as well. So our shape is going to be approximately normal in this case. The center is essentially just going to be the proportion that they give us in the problem itself. It's either going to be 70% for school 1 or 50% for school 2 in this case. Our spread is essentially just finding the standard deviation of those particular samples, which again is just the proportion for success times the proportion for failure divided by the total number in the sample size, and put that all under a radical, take the square root of it, and that gives us a standard deviation for both sample proportions. We can also confirm this through the 10% condition, making sure that that's independent as well. So we know that 100 students and 200 students in both schools is going to be about less than 10% of the total population of those schools, since they are both considered to be large high schools. Okay, so from there, we would need to compare the values. So if we were asked to find the mean of the difference in those sample proportions, what we would do is we would just take sample proportion for school 1 minus the sample proportion for school 2, and that would give us a total of 20% right there. And that's essentially how we find the mean difference in this case. For the standard deviation, however, it's going to be a little different. So we are going to have to add what is under the radical, or the variance, in each one of these. So we would have to take this variance, or what's underneath the radical, add it to this variance, or what's underneath that radical, and then take the square root of all of that, and that's how we would find the standard deviation of the difference in sample proportions in this case. So really, again, difference, everybody knows that means to subtract. We subtract when it comes to mean. However, we're going to add when it comes to standard deviation in this case. So again, if we're just describing a sampling distribution, we have to describe three things: the shape, the center, and the spread. When it comes to the shape, if we want to determine whether it's approximately normal, we have to perform that large counts condition 4 times, basically, because we're checking the success and the failure rate for every single sample proportion. So all of those have to be greater than or equal to 10 in order for this to be considered approximately normal. The center is essentially just going to be the mean of the difference of those sampling distributions. So we would just take the mean of proportion 1 minus the mean of proportion 2. That gives us our center right there. Our spread is going to be the standard deviation of that, which again is the variance of proportion 1 plus the variance of proportion 2, take the square root of that, and that gives us our standard deviation, or our spread in this case. And that's as long as each sample is no more than 10% of the total population itself. So all of that needs to be stated if we're asked to describe our shape, our center, or our spread for any of these sample proportions. Okay, so let's look at an example of how we might accomplish that. Your teacher brings 2 bags of colored goldfish crackers to class. Bag 1 has 25% red crackers, and bag 2 has 35% red crackers. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1, and a separate simple random sample of 40 crackers from bag 2. We want to let the proportion of 1 minus the proportion of 2 be the difference in the sample proportions of red crackers. So part A asks us to describe what the shape of the sampling distribution of proportion 1 minus proportion 2 is, and why is that the case? Well, we know that we just need to perform our large counts condition, basically. We need to take the total number of sample from bag 1 times the proportion for success. That gives us 12.5, which is greater than 10, and the total number in bag 1 times the proportion for failure in bag 1, and that gives us 37.5, which is also greater than 10. We would perform the exact same test, just using, again, a different sample number, a different sample number and different proportions based on whatever those proportions are in the problem for bag 2. Basically. But however, both of those are going to be greater than or equal to 10, so we can say that the shape is approximately normal because the large counts condition is met, and we show our work by writing that out right there. So part A is taken care of. Part B asks us to find the mean of the sampling distribution and show our work. So again, all the mean is the proportion for sample 1 minus the proportion for sample 2, which gives us a mean of negative 0.10, or negative 10% in this case. So the mean difference in proportions is negative 0.10. From there, we're asked to find the standard deviation of the sampling distribution and show our work for that as well. Again, it's just the variance from bag 1, or the proportion of bag 1, plus the variance for the proportion of bag 2, take the square root of that, and we are given a standard deviation of 0.0971, and we can use that standard deviation of 0.0971 since both samples are less than 10% of the total population, because we know that 50 is going to be less than 10% of 1,000, as well as 40 being less than 10% of 1,000 as well. Okay. Now, we want to find confidence intervals for this information, basically. And we need to perform our 4-step process for finding those confidence intervals, basically how we've been doing this whole time. So again, we need to identify the population and the parameter. That's going to be the state portion of this. We need to state our conditions. That's going to be the plan portion of this. So we need to figure out whether it's random, independent, and normal. And again, we can determine independence based off the 10% condition and normal based on the large counts condition because we're looking at proportions. Again, we would use central limit theorem if we were looking at mean, but we are looking at large counts condition because we're dealing with proportions. We would then need to determine the formula for confidence intervals, and that's going to be our do portion of this four-step process, and then our conclude portion is going to just state the conclusion in context of the actual problem itself. So we have to make sure that we complete all of that. And again, when we're looking at checking our conditions for this, we need to check whether it's random, and that's most of the time going to be told to us in the problem. So the data must come from two independent random samples or two groups in a randomized experiment. So all that's to say is that both samples must be random. We can't be given one sample that's not random and another that is, and say that the whole thing is considered to be random. Both samples must be random. When we're looking at independence, both samples must be less than 10% of their total population in that case as well, and they must be without replacement also. So the 10% condition must be met as well, and the large counts condition for every single sample proportion must be met as well. The counts of successes and failures in each sample or group are all at least 10, so they have to be greater than or equal to 10 in this case. When we are looking at performing the actual formula for a confidence interval, again, we would take the mean of proportion 1 the proportion of sample 1 minus the proportion of sample 2 plus or minus our critical value, which in this case we're looking at proportions again, so we're looking at our z value. And again, you can calculate that by going to second vars and inverse norm, okay, for our z value right here. And that's times our critical value times our standard deviation right there. One important thing to note is that this standard deviation is also known as the standard error of the sampling distribution. So if you are asked to calculate the standard error of the sampling distribution, that is simply the same thing as calculating the standard deviation between the differences of sample proportions in this case. So where z is the critical value for the standard normal curve with its confidence level of its area between negative z and positive z in this case. So that's how we would solve for a confidence interval. Let's look at an example of how we actually go about doing that. So as part of the Pew Internet and American Life project, researchers conducted 2 surveys in 2012. The first survey asked a random sample of 799 U.S. teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2,253 U.S. adults. In these 2 studies, 80% of teens and 69% of adults used social networking sites. So we want to find the difference between that. Essentially, we want to construct a 95% confidence interval for the difference between the proportion of U.S. teens and adults who use social networking sites. So again, we have to go through our 4-step process. We state our parameter right here by saying that the parameter is the difference in proportion between the teens and adults that's representative of all U.S. teens and adults who use social networking sites. From there, we need to plan right here. So we are told that both surveys are random, so we're good on the random condition. It's safe to assume that at least 7,990 teens and 22,530 adults are using social networking sites, so the 10% condition is met. In other words, 799 and 2,253 are going to be less than 10% of the total population of teens and adults using social networking sites in this case. And then our large counts condition is going to be met by performing, by taking the sample size for both samples and multiplying it by its rate of success and its rate of failure as well. And we know that all of those numbers are going to be way larger than 10, so our large counts condition is met and our distribution is approximately normal. From there, we perform our do step right here. So we know that the proportion for teens, in this case, that use the social networking sites from that sample was 80%. The proportion of adults who used social networking sites was 69%. The number of teens surveyed was 799, and the number of adults surveyed was 2,253. Again, we're working off of a 95% confidence interval, so we can go to second vars inverse norm. And remember that when we're trying to find this critical value here, we have to account for at least one of the tails on this normal distribution. So we would have to say that our area is going to be 0.975 because we have 5% left on either tail. We need to take 2.5% of that and add it to our confidence interval, or our confidence level, of that. And then just keep 0 and 1 as the mean and standard deviation. And that's going to give us a z-value of 1.96 in this case. From there, we would take the the proportion of sample 1 minus the proportion of sample 2 plus or minus our critical value times the standard deviation, and that's going to give us a confidence interval of 0.076 to 0.144. So our conclusion part is stating it in context right here. We are 95% confident that the true difference in U.S. teens compared to U.S. adults that are using social media is between 7.6 and 14.4% more in this case. Now, instead of doing all of that math, what we can do was when we looked at just one single, when we looked at just one single sample proportion in this case, or when we tried to find the confidence interval for one sample, what we need to do in this case is we need to select 2 prop z-int instead of 1 prop z-int in this case. So again, all you need to do is go to stat, arrow over to tests, and then arrow down or arrow up until you get to the bottom of the list, and you should see B is next to 2 prop z-int in this case. And so from there, all we would need to do is we would need to fill in our fields right here. Now, in this problem in particular, they don't give you the total number for successes and failures. They just give you the proportions themselves, so 80%. So what we would need to do is we would need to find what's 80% of 799 and what's 69% of 2,253 in this case. And that's going to represent x1 and x2. So these are the proportions this is the proportion of teens who use social media. This is the total number that was in the sample of teens who they actually sampled. This was the proportion of adults who use social media, and this was the total number of adults sampled right there. And then for our confidence level, we're just putting in the 95%. We're not accounting for the tail in the confidence level for the 2 prop z-int function on our calculator. After that, we hit calculate, and we should see our confidence interval pop up right there, and we are pretty much good to go. One last tip for the AP exam and for these readers. The formula for the 2 sample z interval for P1 minus P2 often leads to calculation errors by students. As a result, we recommend using the calculator's 2 prop z-int feature. So they want you to use this. Don't shy away from using that. It's a heck of a lot easier than doing all that math, and it's probably going to get you the right answer. So they want you to use it. However, you need to be sure to name the procedure to proportion z interval and give the interval that they actually give you as part of the do step for this problem. So just make sure that from that, it appears like you will not have to write out the entire formula. However, you do need to list this, or say that you used 2 proportion z interval and then actually give the interval itself in order to get credit for the do portion of that step.